I came up with this idea that I wanted to get more airflow through my cabinets, so and into the garage as well. So what I did, let me turn this camera around here 1 second. This is my dining room area. I've got a seat here, another seat here with storage underneath. This is my garage wall right here. What I did is I installed some fans underneath both seats. All right, my circulating fans, there's one there and there's one right there. That's gonna suck air from underneath the seat into the garage area. And then this one was supposed to pull air into under the seat there, so it gets air flowing throughout the garage, and it also gets air flowing underneath the seats, and hopefully they're through the rest of the cabinetry. That's the plan. I bought these cheap computer fans, and I didn't research them enough. They don't put out very much air flow. When I originally designed the garage fans, I wanted it so that when the ceiling fan is blowing air out, then the two fans, one would push air this way, the other fan would push air that way. And then if the garage fan or the ceiling fan was sucking air in, then the two garage fans would go in the opposite direction. That's what I was hoping for. But those motors don't work that way. They only blow air in one direction. So that means that when I reverse the polarity, they aren't going to change direction. So unfortunately, they're only going to work when the ceiling fan is either blowing air out or sucking air in. And by having one fan face this direction to blow air that way, I just flip the other fan the other way so that it'll push air that way. That's how I control the airflow. And it just doesn't work if I'm sucking air in when I've got the garage fan set to auto like that. So as it sits, that's how it is. Air flowing out. With this in auto, I got airflow going through my seats into my garage and coming back out the other way. The flaw that I do have with my garage fans, like I said, is that the polarity is not reversible. I tried researching it as hard as I could before I bought it, and I couldn't get a definitive answer based on what I seen, what was available to me. So I bought them, taking a chance, and yeah, it didn't work out. So the way that these fans work for me is I wired them up so that when the fan is blowing air out, they can turn on when the switch is in auto. And if the fan is sucking air in and that switch is in auto, it's going to be forced to work in a way that it doesn't want to work, that the fans aren't meant to work. So what can happen then is you can either have a short circuit and it'll just trip the breaker for the fan itself. It could damage the motors, and the fans in the garage will just not work anymore, and I got to replace them. The wires could heat up actually too, and they could melt, and boom, you could start a fire. I mean, that's very, very unlikely, but what I'm trying to say is doing it the way I've done it is a bad idea. Unless you don't have an in and an out with your fan itself. If it just goes one direction, then you're fine. So if your fan does both directions, then I strongly recommend making sure that your fan, the garage fans that you install or wherever you put them under your seats, goes in both directions to match your ceiling fan. So I bought these bad boys here. These are actually for cooling radiators. I'll put a link for them somewhere. I'll put it, I don't know where yet. Anyway, what I'm gonna do is they're bigger than that. They push out a lot more airflow. So all I'm gonna do is just cut off this useless end here. Just like that. Put it right in the fan blade because that's a good idea. And I'm just gonna, it's just usually your reds, your positive, your blacks are negative. I'm just gonna hook it up to the existing wires. Now because these fans were put right where they are, I've kind of put myself in a bit of a pickle here and to try and cover up the existing hole or use the existing hole there. This won't fit in because this goes right up against that 2x2 there. So normally I would just move this over more so that I wouldn't have to cut this off, but because the situation, I'm just going to cut this off with a saw, and I'll use these holes for holding it in place. I'm wiring up my new switch to the garage fans. I got the old one wrong. I've got my double pole, double throw on, off, on switch. So this is off. That's on in one direction, off, on in another direction. So what I'm going to do is, from my two fans that I have literally underneath my seats, I'm going to put the positive here, the negative there. And then on this side, I'm going to have the negative and the hot power from my leisure batteries. And then over here, I'm going to do the same thing. The hot and the negative from the fan itself is going on here. And so when it's off, it's off. If I turn it on this way, then I believe it activates the one from the fan. So when the fan is on, my fans down below will be on. And if I turn it the other way, then it's the fans are turned on from the power, permanent power. So it's on manual, so to speak. So manually turned on is just turn on, and auto is when my ceiling fan is turned on, they turn on. Now what I did, I got a little clever, and with a lot of work and a lot of help on the internet, and I found out how to take a 4-speed fan that goes out only, and I made it any speed I want, and it can go in both directions, and I'm also controlling it from 2 different places. Installing the fan. So this piece just drops in. That's pretty straightforward. Then you hook up your wiring. What I did is these guys here hook up, are supposed to hook up to the to your power source, and then everything is ran through the circuit board. And when people often complain in the forums on the internet and YouTube videos about their Maxx Air fans frying and needing replacements and struggling with customer service, and at any rate, this is the issue. The motor, it's, from what I understand, and I could be wrong on this, these aren't rated for 14.7 volts, which is roughly the max that lithium-ion batteries will output. So they're rated for 12 and a half volts or something like that. This is my theory. I'm not saying it's true or accurate. This is what I'm theory. So the higher voltage causes these to blow and their fans don't work. But if you're ever in that situation, the motor still works fine, most likely. It's just this that's gone. So what I did to prevent that from happening, and because of the setup that I have, which I'll explain here in a second, I just bypassed this altogether. And I went right from the motor wires. These are the wires that come from the motor itself, which is on top of here. And I hooked it right into the power source. So this is doing absolutely nothing. And I'm controlling the motor directly without... The downside is I can't use this setup, but I really don't care. I never would have used it anyways. So now that we got the fan all back together again, let's show you this skookum setup that I made here. Right over here is my control center for one of the two anyways for my fan. I have the fan here under cabinet lights, my kitchen lights, and the inverter. So I really can't turn on my fucking lights. Getting off topic. All right. First of all, we have this switch right here. I can have the power or the fan blowing air out. I can turn it off, or I can have the air being sucked in. This allows me to control the intensity of the fan, which you're going to see. Let's just turn it on right now. It's sucking air out right now. Let's see. Yeah, it's sucking air out. This allows me to control whatever speed I want. And then this guy here, this just allows me to control the fan from the bed. I'm not going to touch it right. If I was to flip it over right now, then the power to control the fan would be held over at the bed. So I can do that here, or while the fan's going. Let's just say it was hot and I wanted to cool the van down before bed, and I got all comfy, or my feet were stinky, whatever the reason. Now when it's time to go to sleep, I gotta get up and go all the way over there to turn this fan off. So being lazy, I didn't want to do that. So I've got this set up here. It's a carbon copy of that one over there. So what I do is, as you can see, I've got it out, off, and in. And by swapping the power over to here, because the fan's turned off here, it just kills the power and the bag falls to the floor. Okay, so now I can turn on the fan from here. And when I was doing this video, this is like the third take I've done, I realized that I installed this switch backwards. It's actually supposed to be turned 180 degrees. Because when I turn it up like this to have air go in, it's actually sucking air out. So just to show you, air is being sucked back out again. I'll swap this out later on. I can control the intensity from here. Life is good. And then, so we're pretending for this video that that's out. We're going to shut it off and wait for the fan to stop. You don't want to switch directions while the motor's still moving, because that's really, really hard on it. And there we go. So we're actually, it's supposed to be going out right now, but like I said, I got it backwards. So now it should be sucking air in to the van. So let's use this, and if it's actually sucking air in, this won't stay, and it doesn't. So it's pushing air into the van. Works the same from over there. So that's how my ceiling fan works. It allows me to control everything from two locations. I can turn on the fan here and then get up and start cooking, and if I don't need it anymore, I can turn it off from there by either just swapping the power over to it or simply turning off the fan like that. It's a good idea, if you're going to do this setup, it's a good idea to turn off the fan here instead of just swapping power, because if at the other end you have this set to go the opposite way and you swap it over, it's just hard on the motor because it goes from going super fast one way to all of a sudden going really fast in the opposite direction. So how did I make all of this work? All right, so inside of here is the brains, the computer, the whatever you want to call it. I'm going to be showing you how the wiring works for all of this after I'm done giving you this physical explanation, I guess you can call it. So don't worry about the wiring yet. It'll come here in a second. But these, like I said, this is just a three-way switch that brings power to there or back to here. This one here is got a whole bunch of contacts in there. There's 6 contacts, and it allows me to reverse the flow of electricity. And what I mean by that is, if you can imagine that these are the contacts for the fan, you bring in your positive and your negative, and the positive and negative wire from the fan is going up this way. That makes the fan go in one direction. Great. Now, if you were to reverse those around so that it's reversed polarity, as they say, and your positive is now here and your negative's here, then the fan's going to turn the other direction. That's how you get a fan to go in and out, to slurp and burp, as they say. So not all motors do that, by the way. I got lucky. I always thought that they all did, but they all don't, or not all of them do. This one does, so I can reverse the polarity just by the way I wired in this switch here. And then the intensity of the fan, how fast it's going, is controlled by this guy here. So, and there's one of the fancy knobs that I got with it. Now, here's this god-awful mess that looks like my hair in the morning. This here is the switch that allows me to reverse polarity for the motor. Here's my three-way switch. And then this is the PWM controller. So it's basically just a circuit board. I had to mount it this way in order to get the shaft of it out here. So one of the guys at Makerspace was kind enough to create this 3D little bracket out of plastic. And these 2 screws here go through there, and they screw through on this side and that side. That holds this into place. And then I can't get the camera in there to show you, but on the other side of this circuit board, there's screw holes. There's one in all 4 corners like this. So I got a screw coming through there and into here. And I did one in that corner and one down there as well. And we just made the holes a tiny bit smaller than the size of the screw, so that when you screw it in, it creates its own threads, because the plastic will work that way. It wasn't an issue. Tired of spending big bucks on deck boxes for your trading cards? What if you could make your own, and from the cereal box in your own kitchen? At the Cardboard Stencil Company, we give you the stencils, guides, and videos to turn everyday packaging into durable, foldable deck boxes. It's fun, creative, and works with all of your favorite games: Pokemon, Magic, Yu-Gi-Oh, and more. Pick your favorite packaging, print a stencil, cut, fold, and boom! You've got a custom deck box that's clean, cool, and totally unique. Why buy when you can DIY? Visit cardboardstencil.ca today and start building your first box. And the way that I could do that is with a couple of these relays. And once you understand how relays work, they're fairly straightforward, fairly easy. But if you'll notice that I bought the relays. Relico is the brand. They've got a great reputation based on the supplier that I bought them from. And you want to get the base for them as well. And you're also going to need some rail so that you can mount these onto. So I spent $10 for a 4-foot chunk of rail to use about 8 inches and get rid of the rest. And you screw that into the wood. This slides onto the rail, and then this plops into there. All your wires go into the slots inside of this base, which you can kind of see right there. Can't get my phone in very far, sorry. But you got an idea there. That's how you run the wiring into there. That's all there is to it. So let me explain now how I wired all of this in between the front and the back. All right, let's start off with adding in a box for the kitchen. That's going to be the area where all of the switches and relays are, in that area. And then we'll put another box in the bedroom area here. That's where the switches are held there as well. Next, we're going to put up a ceiling fan and some circulating fans. Now we've got to start populating with all of the stuff that makes it switch and turn on and off and all of that fun stuff. So we'll start off with the motor controls. There's one in the kitchen and one in the bedroom there. That's the little circuit board set up there that allows you to control how fast or how slow your motor turns on your ceiling fan. Then beside that, we're going to put a double pull, double throw on, off, on, a reversing polarity switch. This goes in the kitchen and the bedroom and is how you literally reverse the polarity of your fan to make it go the other way. Beside that, we're going to put a couple of 3-way switches in. They're single pole, double throw, on switches. This allows us to swap power from the kitchen to the bedroom and back again. Next, we're going to put in 2 relays over in the kitchen area. And that one's going to be discussed pretty quickly. Finally, beside the bedroom on the wall, at least in my van, we're going to add a double pull, double throw, on, off, on switch. It's not for reversing polarity this time. This is going to allow us to control the circulating fans from the ceiling fan, turning them on and off, being able to manually turn them on or off, or just leaving them off. And finally, the 12-volt panel where the power source comes in. Let's explain how to wire all these in. Let's get started by explaining how an 8-pin double pole, double throw relay works. Now, not every brand is labeled the same as this, and the configuration might even be slightly different. So if yours is different than this, then unfortunately you're just going to have to figure out how to make the comparison yourself. So to start off, with this setup here, you can see it with the 8 pins. If you look really closely, you'll notice that pins 1 and 8 are on the very bottom there. They go up just like I've shown here with the highlighted red and black. And in this diagram, they rest against the contacts for pins 4 and 5. So pins 1 and 8 are constant power coming in, at least in my setup. And when this Relay isn't energized. Power goes up pins 1 and 8 through 4 and 5 and out to the first load. Now on pins 2 and 7, when power is brought into those pins, it energizes the coil in the relay and it causes this flap here and this flap here to go over to the other side, which then energizes pins 3 and 6 and brings electricity to the second load. Pins 4 and 5 go dormant, there's no power to it, and it does nothing. As long as power is being fed into pins 2 and 7, the relay will stay exactly where it's at. The moment electricity is taken away, the flaps move back over to the other side, and power is again restored to pins 4 and 5. That is, in a nutshell, how this relay works. So let's get started with how we're going to wire this in next. The first thing that we need to do is get power to all of this stuff. And since the relays are going to be one of the starting points for how this whole electrical setup works, we're going to bring power from the electrical panel all the way up to pin number 1 on relay number 2, pin number 7 and 8 on relay number 2, and all the way over to pin number 7 on relay number 1. Now the sole function of relay number 2 is to bring power to the motor control units. So if you'll notice on pins 6 and 3, power is brought over to the motor control unit in the kitchen. And at the bottom of relay number 2, pins 4 and 5 has power going to the P plus and the P minus for the motor control unit in the bedroom. P plus obviously is power positive, P negative is the negative for the power in. That is the sole purpose of relay number 2, just bringing power to them. It doesn't do anything else. What happens with pin number 2 on both relays will be explained shortly here. Now, if we go over to relay number 1, the sole purpose, really, of relay number 1 is getting the power to the ceiling fan. And in order to do this, the power must first come out of the motor control unit. Let's start at the bedroom. And notice how it goes into the bottom of the double pole, double throw, on-off, on switch. And from there, what I've done is I crisscrossed some wires and attached to the terminals, like you can see there, so that when power comes out of this switch from the top, the polarity has been reversed. That's how we make it happen. Now, for power to leave this switch, it has to come out of the center contacts, like shown. So depending on which way the switch is turned will determine which way the electricity is leaving there, if the positive is on the left or on the right. This is where the reversing of the polarity for the ceiling fan happens. Out of the contacts, it goes all the way up to pins 4 and 5 on relay number 1. And then the same process happens out of the kitchen with the same reverse polarity switch. And if you'll notice, out of the center contacts, it goes over to pins 6 and 3 on relay number 1. Now, there's something very important about this that you need to pay attention to. If when you get this all wired up, you find that your ceiling fan isn't working properly, you're going to want to pay attention to this part here. Because if you'll notice that for the kitchen area, the reverse polarity switch is done with pins 6 and 3. And on relay number 2, the motor control is handled on pins 6 and 3. The motor control and reverse polarity switch in the bedroom are both handled on pins 5 and 4 for each of the relays. That is very important to make sure you get right, because if you get it backwards, when you go to flip power on to the kitchen, you might have your reverse polarity switching working there, but the motor control will work in the bedroom, or vice versa. So if you're finding that's happening, you've most likely just gotten your wires mixed up. So pay attention to the way the wires are ran and make sure that they go into under the proper numbers in the bases. And one more final thing on this. When you've actually got the base that your relay sits in, the numbers are not going to be set up exactly like I have here. Though I've done it this way just to make it easier to run the wires for making my diagram, and so it doesn't look as confusing and crazy and really, really busy. So look at your relay, figure out the numbers, and make sure that the wires are ran in however they're set up. Now, how does the ceiling fan get power to it? Traditionally, when you're using a relay, like I said, power comes in pins 1 and 8, and then it goes out either 4 and 5 or 6 and 3. That's traditionally how a relay is used. When I was making this setup, I couldn't find a way to be able to make the reverse polarity work with the ceiling fan. And then it dawned on me that I don't have to run power in at pins 1 and 8. I can actually send power out of pins 1 and 8. So what I did is with power coming from the reverse polarity switches into pins 6 and 3 and 5 and 4, I can now shoot power the other way through the relay, have it come out on pins 8 and 1, and go directly into the ceiling fan. By doing it this way, I am allowing myself to control the fan in both directions, in and out. Because what's important to understand here is that you cannot reverse the polarity of the ceiling fan before the electricity goes through the motor control unit. It's not designed to work the other way, the PWM. So you have to do it after the electricity has gone through it, which is why the reverse polarity switches come after it. Once it leaves the polarity switch and goes through the relay doesn't care which way the polarity is. It'll work all the same. So as it leaves pins 8 and 1, regardless of the way that you have the polarity of the electricity coming into it, it'll go out those wires and into the ceiling fan just the way that you've set it up. Now from there, in order to be able to operate the circulating fans, if you'll notice the double pull, double throw switch down there, power and a positive and a negative from the ceiling fan comes down to the top contacts there. Now, how you wire in all of this from pins 8 and 1 to the ceiling fan and down to the contacts is up to you. As long as all the wires are touching together, that's the important thing. And as long as you're not putting too many wires in a contact area for tightening down wires, like either in the ceiling fan or in the relay, or overloading the contact on your switch. So that's up to you to figure out. Just keep that in mind. The center contacts in the circulating fan control switch, one goes over to the positive on the circulating fan and then jumps over to the positive, the second circulating fan. And then on the other side of the center of the switch, the negative, you can see, does the same thing. This completely isolates the circulating fans. And that matters because, as you can see, the power coming down from the circulating fan goes into the top. When the switch is flipped and the contacts touch each other like it's shown right here, and if the fan is blowing out, then these ceiling fan or the circulating fans will blow the way that the arrows are showing that they blow. If I was to reverse the polarity of the fan, keeping everything else the same, then both circulating fans would start blowing in the other direction. Once again, make sure that before you install these circulating fans, test them and make sure that they can blow in both directions. If they can't, you're setting yourself up for all kinds of problems between blown fuses, melted wires, or potentially blown ceiling or circulating fans. So that's a very, very strong warning right there for you. Now, if we turn this double pole, double throw switch off, put it in the off position, then there's no contacts touching anything, and therefore no power is going to the circulating fan at all. So no matter what's going on with your ceiling fan, nothing's happened down in your circulating fans. If you were to flip the switch to the bottom side and put it in manual, then as you can see, there's a power coming up from the 12-volt panel to the right side of the switch, and a negative going right back to the panel again. That allows you to, and if you pay attention to how the contacts are now touching each other, that turns on the circulating fans by themselves. And it has nothing. This is working independent of the ceiling fan, so you can turn your circulating fans on by themselves if you want them on. You just have to remember to turn them off again. If you've got it set to auto, which is facing the opposite way, then anytime your ceiling fan comes on, your circulating fans will come on. And once again, as long as the circulating fans can go both directions, it doesn't matter if you're sucking air in or blowing air out, your circulating fans will just swap directions the same way that your ceiling fan does. Now, you still may be wondering, well, how do these coils in the relays get energized? And that'd be a great question. For that, we have to look at our single pole, double throw, on switches that swap the power between the kitchen and the bedroom. If you'll notice in the diagram that there's one in each area. Now, in wiring in residential housing with 120 volt electricity, if you notice there's 3 contacts on each switch, we would call the 2 contacts that are together the travelers, and the 1 contact by itself, we would call it the common. I don't know if it's called anything different in DC electricity, but for today, we're just going to call it the same thing. So, what I'm going to do, instead of explaining how to wire in this 3-way switch here, is I'm going to show you another little video that I've made on how to wire in a 3-way switch. And then we'll come back here and show you how it all ties in. This is how we wire in a 3-way switch. To start off, let me explain the basics of some switching. This is just a regular on-off switch. Just turns one circuit on or off. Any kind of load you want to put on it. It's just got the 2 contacts here, okay? With a 3-way switch, it has 3 contacts. And then you can turn a load on or off, and a load can be a motor, it can be a light, it can be anything you want. You can turn it on or off from 2 different locations. And the way that works is by having that extra contact. As you can see, it's got a 3rd one, whereas the on-off switch doesn't. Okay? There's all kinds of different uses for a switch like this, but for today we're going to use it as a 3-way switch. So when I say 3 contacts, I'm referring to these 3 spots here, okay? And this guy in the middle, In 120 volt electricity, we call this the common. So I don't know if it changes in DC electricity, but for the sake of this conversation, we're going to call this the common. All right, so let's get started. The first thing that we need to do is draw out 2 3-way switches. So there's your common right there. And there's your, for the sake of 3-way switches, we call these the travelers, okay? These outer ones, common and the travelers. I'll explain why as I draw this out. So there's switch number 1. Over here, we have switch number 2. They each have a common and they each have a set of travelers, okay? We're doing great so far. And then over here, we're going to have a pretty little light, okay? That gets turned on when you turn on these switches. All right, once again, this can be anything you want. It can be a motor, it can be a light, it can be anything. Okay, so the first thing that we need to do is we need to get power to this light. And in order to do that, we need to bring it in on one of these commons. It doesn't matter which common you use, but you need to get power in. So we're going to bring power in right there. And we're going to call this 12 volt. 12 volts positive coming into this common, okay? Now we need to get power down to this end of the switch so that we can light up this light. But before we do that, let's get power from here over to this light. So what we will do is we will come over like this, and this is your 12 volts positive. So the first common has 12 volts power coming in, and the second common brings 12 volts positive to the load itself. All right. And then from the load, your negative is going back to the panel or wherever you're going. So you got 12 volts negative. Okay, that's the negative side of the load there. When it comes to these switches for a 3-way switch, there's no need for a negative. There is no negative to worry about. In DC electricity, the negative only comes on the other side of the load itself, like I've done, okay? So all that's left now to do is to add in the travelers. I'm going to mimic that we're using some 12 volt wiring of black and red, and I'll use that for the travelers because in real life that's what you would do. So all you're going to do, if I can get my pen to work, okay, we're not getting electricity today. I'll have to switch to blue here. One of your travelers would go across like that, and then your other traveler goes across here. So this is one 2-wire piece of wire right here, okay, even though they're far apart. That's all the wiring there is to make a 3-way switch. Now, how does it work? That's a great question. Let's use green just because I have the colors here. When you turn on or off one of these switches, there's a set of contacts in there that allows this common to touch this contact. And if you flip the switch the other way, this common touches this contact. So it just literally goes back and forth like that. It's just like a little flap or whatever you want to call it, okay? So that's all that's happening. So when I draw it the way I'm going to draw it, hopefully you'll understand that that's all that I'm talking about. So as it sits right now, we're going to pretend that the contact is set up to go over here, all right? If I were to flip the switch, the contact would go over to here. So when I've got the switch flipped to here, power goes down this traveler to here. If I flip the switch over, power goes down this one to here. So no matter which way I flip this switch, power is going down one of these two avenues to this switch. All right? This is great. Now, if this switch was set over here like this, power goes through the flap to the common, goes over to the light turns on, and the negative side goes back to the battery. Everything's working just fine. Okay, great. Now let's pretend that I flop this switch over to here. Okay, power's coming down here, goes through here, and remember, we're pretending like this isn't there. Power stops here because your common is going over to here. So power does that. By flipping this switch over to here, this light turns off because power is stuck here. So if I were then to turn this switch on, or the other way, then power comes into here, goes to here, comes down to here, and because this is already switched over to here, it goes into the common, down through the load, turns on your light or your fan or whatever, and then goes back to the panel. Three-way switches are that simple. And even if you don't understand how the concept works, as long as you can understand to get a 2-wire from your travelers on one switch, which once again are these guys, if you can put 2 wires there and then do the same thing on the other end, put the travelers on the other outside contacts, and as long as you can bring power into one of them, just the positive, that's it. And then at the other one, if you can bring 1 wire all the way up to the light, and then the negative back to the panel or wherever it goes, depending on your setup, that's all you need to know. Your circuit will work just fine. Hopefully that made sense and that you have a better understanding of how to wire in these 3-way switches. Well, let's carry on here. So if you'll notice in the bedroom there, and where the common contact is, power's coming in directly from the panel. And you might even bring it in from another source. It doesn't matter. As long as it's getting permanent power, that switch can do its job. Now, based on the setup that we have here, the contacts are set up the way the switch is to bring power down the left traveler, carry through to the common and in the switch in the kitchen, and it carries on over to pin number 2 in relay 1 and relay 2. If you remember from the relay diagram, pin number 2 and pin number 7 are what energizes the coil. So by doing this, with this setup, power is now going to the relay. It's energized the coil, and it's flopped the contacts over so that the other load coming from the relays is now got power. This is pretty much how the entire system works. Let me go through the whole thing a little bit faster now, and hopefully it'll all make a lot more sense. From the 12-volt panel or wherever your power is coming from, power goes directly up to the circulating fan control switch, over to the common on the swap power switch in the bedroom, and then it also carries on all the way over to the pin number 1 on relay number 2, 8 and 7 on relay 2, and number 7 of relay number 1. That gets power to your relays and to 2 of your switches. You've ran your travelers across for your 3-way switch, which is great. And now out of relay number 2, you're bringing power down to both of your motor control units, making sure that you use the same pins, 4 and 5 for bedroom, 6 and 3 for the kitchen. And because you are only controlling power from there, to get power from the motor control units to the ceiling fan, you have to go through the reverse polarity switches. So as you can see on both switches, on the motor side, you're going to go into the bottom of the reverse polarity switches like I've done. And keep in mind, you don't have to do the bottom. If you want to put them in the top of your switch and do it the opposite of what I'm doing, that's fine. This part here has to go in either the top or the bottom. That's all that matters. Because once you've done that on both switches, out of the middle, it has to be the middle, power leaves and goes back into relay number 1. Keeping those numbers the same, 6 and 3 for the kitchen and 5 and 4 for the bedroom. Now power has gone through the motor control. It's gone through the reverse polarity switch. So now with that flip of a switch, you can make the ceiling fan suck air in or blow air out. And then it's going backwards through relay number 1, no matter which way you're controlling, from the bedroom or the kitchen. It's reversing through the relay, coming out pins 8 and 1 and going directly into the ceiling fan. Now your ceiling fan is either blowing air or sucking it in. And from the ceiling fan power, whether you do it at the ceiling fan itself or you tie power in at pins 1 and 8 on relay number 1, however you choose to do it, power goes down to the top of the circulating fan control switch, the double pull, double throw, on, off, on switch. Once again, you can put it in the top or the bottom. It doesn't matter. Just don't put it in the middle, because the middle goes directly to the circulating fans. And whatever side you haven't used, the top or the bottom, you're going to bring permanent power in from the 12-volt power panel. That way you can control the circulating fans manually if you like. And because it's an on-off-on switch for your circulating fan control, if you put it in the off position, it doesn't matter what you're doing. No power's going to the circulating fans. They're isolated. If you wanted to work on them or just leave them off, that's just the way you do it. And because permanent power is coming to the swapping power 3-way switch in the bedroom, it can travel up the traveler into the relays, and that's what causes the coils to be energized or not. With this setup, you should be able to control your ceiling fan and add in your circulating fans the same way that I have. And if you want to add in more ceiling fan or circulating fans, then just keep on bringing the negative and the positive from the last ceiling fan to the next one, to the next one, to the next one. Well, I hope you liked today's episode. I'm still walking down the mountain while you're finishing this up. If you liked it, then hopefully you'll like the next one. I don't even know what it is yet. But have yourself a great day, and thanks for watching.